Okay, we're recording. Yep, we're good.
All systems go.
Ready?
Ready. Well, we're here.
How did Kaizen begin?
It was a long time ago in Japan.
Yeah.
I don't know. How did our Kaizen begin?
1300. That was a year.
I wasn't
Something
there for
like that. It began with this crazy idea that let's improve, but in a consistent way, so that every 10 Ship It episodes, we'll talk about the improvements that we drive in the context of changelog. Share them publicly, and that was our reminder that, hey, 10 episodes, we'll be talking about everything that we've done. Some called it navel gazing. I don't think that's what it was.
That was me, probably.
Jared.
It was good fun. And yeah, it's been 4 years. It's been 4 years.
It's been 4 years.
It's been longer than 4 years.
Has it?
A decade. We've been
Since we've been-
Kaizening
yeah,
a decade.
yeah,
We just
okay.
started
Going
calling
way
it
back.
We've been
Kaizen.
calling it as a Kaizen.
Yes,
So
so-
Kaizen 1 was about 4 years
Kaizen
ago.
as it is materialized roughly 4 years ago, but the relationship,
That's
the reason
right.
why I bring that up is I want to say one thing. Is like, these guys are my ride or die people. Gerhard's amazing. Jared, you know you're amazing. But
I
like,
know I am.
the magic and the beauty that's come from this relationship has just been tremendous. And to be here and share that with you all, and to share Kaizen 20,
Yeah.
this navel-gazing approach to our platform, but this constant attention to detail of improvement, and I think particularly with what we'll talk about today, is unique to us specifically in that we built some infrastructure that's used by us specifically, where a behemoth, not negatively, is just not maybe the right fit, and we've been holding it wrong to some degree. But
Right.
this, what we're doing here, is just a wild ride, and I'm excited for this moment. So
Is there a way to hold it right? That's the question
yes.
I continue to ask myself. It turns out, if you gaze at your navel long enough, there's cool stuff in there.
Definitely.
So
But
thank
it
you for
has to be
joining
long
us.
enough, but you have to do something
As we
about it.
pull out
You have
some
to
of
have
our-
a proactive approach to it.
Yeah, we pull out a
Otherwise,
few of our treasures that we've found along the way, and something that we've built over the last. When did we start Pipely?
Pipely was, I think, 18 months ago, roughly. The idea was, shall we do this thing? I mean, we've been talking about it long enough.
Yeah.
Shall we actually try doing something about it? And the beginning was, as all beginnings, like, can we do this? How long will it take? What will it take? Do we know what even needs to happen? And that's how the conversation started. And many of you that have listened to those conversations remember us, right? How we were pondering, should we not? Are we crazy? Three wise men, the question mark was really the emphasis. Like, are we wise doing this? We have no idea.
Right.
And then along the journey, the best part was the friends that joined us. So it turned out there was not such a crazy idea. And just the idea of improving something in public so that others see how we do it, and it's our approach, and maybe it will inspire others. And I think that worked really well. And here we are today with friends.
with friends.
And that's, again, that's the focus. So improving with friends makes me so happy.
Yes.
Thank you all for being here for that.
Thank
for
you.
sure.
We appreciate you very much.
Absolutely. So it all started with a dream,
Yeah.
a pipe dream,
Indeed.
on a Kaizen number that I can't remember.
13, I think.
Kaizen 13.
I think so.
When we were lamenting our cache miss ratio on
That was it.
Fastly, but they had this really nice Varnish as a service that we've been using for a long time. We just didn't like the way that we had to use it through Fastly, which is through a web UI,
Yeah.
and a strange comment-based versioning control system that we invented on top of it, called
Yes.
put the name of the person who does the thing and the thing you're doing as you update the config, which would produce this gnarly, I don't know, 1,000-line Varnish config that would work mostly sometimes.
Yeah.
And it was great when it worked, but when it didn't work, it was very difficult for us to have visibility and debuggability in order to fix that. And so I said on Kaizen 13, wouldn't it be cool if we could just have this 20-line Varnish config
Yeah.
in the sky, just deployed around the world, and it could just be, just for us, everything we need and nothing we don't. And Gerhard got a twinkle in his eyes.
Yeah.
And he
I love a
said,
challenge.
20 line, I can give you 500 lines.
Well,
can make.
I think it's close to 1,000 now, but
Okay.
anyway.
So it was a
there's
pipe
reasons.
dream. But
Yeah.
that began our journey down this particular path, which we are at the end of, or a milestone at least. You're never at the end of this kind of a path.
Nope.
Where we decided on our Kaizen 19, hey, we're ready to run this. We call it Pipely is the open source project. Pipe Dream is our instance of that because this has been our pipe dream. And we're there. We're almost
We are.
there. We're there now.
Yeah,
But on
we are
Kaizen
there.
19, we were like right at the precipice.
We are there.
And I said, what if we just get together and do it together?
Yeah.
And you guys said, yeah. And I was
Let's do
like,
it.
how about on
Yeah.
stage in Denver? And they're like, sure. And so here we are.
Yeah.
There's your setup, Gerhard. The way Kaizens usually work is Gerhard works way harder than Adam and I do. And he
We show up.
prepares. Yes. And I say something like, Gerhard, take us on a ride. Tell us what we're going to do. And so, Gerhard, take us on a ride. What are we going to see today out of Pipely and Kaizen 20?
Thank you very much. So we will start with a little bit of history so that everyone is able to visualize a couple of very important milestones. Then we're going to ask you a few questions. So you better think of some good questions to get back at me or at us. So let's see how that goes. And then we'll do something special because everyone took their time. This took considerable effort on all your parts to be here. And we want to recognize that effort by doing something special on stage live. So let's see how that goes.
What are we doing?
All right, so first
That's
of
what you
all,
gotta
let's
tell
start with the beginning. The beginning is July 26th, 2025. This is an important moment. We're all here today. It's the first time that this is happening. Kaizen 20 is the moment. Thank you all for being here. I'm sure that you all know this. Now, it says 20 episodes. Actually, it's 19, like one was republished, but it's been 19 Kaizen episodes. And this started actually in 2021, in July. Like, I had to look this up. I wasn't sure exactly how long it was, but that's when this started. So this journey, officially, when we started having these conversations, all recorded, all remote, happened many years ago, and it took us this long to finally do this in person.
10 years.
Right. And if you count exactly, like when
10
this
years.
like unofficially started, yeah, it's been a decade.
It's been a decade.
So we're good
26
friends
I'm
now.
stretching it by one. 2016 was the year we launched what is now our platform. It's an open source platform, changelog.com. You all know that. It's on GitHub. Some of you contributed. You're probably in the issues or at least reading them. But it's been a journey. It's 2025. It's not quite 10 years, but I'm rounding up. Help me
Yeah.
out here. Give me a gimme.
Yeah. Next year, maybe
Yeah,
we
you
do
kinda
something
ruined our
even
10-year
greater,
anniversary.
right?
That's right.
Maybe we're building up to that.
jumping
Cool.
the gun.
Okay, so the reason why we're doing this is because it's about friends. This is the new context. It used to be Ship It. Before it was unofficial. It used to happen just among like a few people. And now all of you are here. And we appreciate you. So thank you very much. Because as you know, it's so much better with friends. So changelog and friends is the context. And including friends that want to be here, but maybe can't. Next year, hopefully, or the next time we meet, it's a good reason to make this crowd bigger. But this is how it began. This is the first moment we have met in person, and it's amazing. All right. Now, you haven't noticed here, but this is something that I pay attention to because the person that takes the pictures is never in the pictures.
True.
So we need to acknowledge the person taking pictures.
There he is.
And that is Aaron. He's over there. He's
Aaron.
filming.
Thanks for coming, Aaron.
Hey,
Let's hear
thank
from
you very much. So, yeah, thank you for being here and capturing this moment for all of us. That's so great. So, we are friends. I think we can call ourselves friends when we go for a beer and we go for a hike and we share a meal. So that's, I think, what it means to the beginning of a nice friendship, that enjoy making things better. That's really what brings us together. And we do it in a public way. We share. And even when we get it wrong, that's fine. Because it's always about improving. It's not about being 100% right or knowing it all, figuring things out. And that makes me so happy. So, you all know this. We post these as discussions on the changelog.com GitHub repository. This specific Kaizen is discussion 546. And if you want to do a bit of digging to see what went into making this Kaizen, that's where you can go for like the technical stuff, for the pull request, for the code, all of it is there. And I think the first step that we need to do is set the record straight. And the reason why I remembered it is because of that very small thumbnail. There's 3 people there. There's BSD PHK. So PHK is Poul Henning Kamp. I didn't know who he was until recently. He is the guy that had a huge contribution on FreeBSD, NTP time counters, FreeBSD jails, MD5 crypt, and you all know this.
Can I say it?
Yes,
The bike shed.
that's it.
That's right.
Bike shed.
Yeah.
He invented the bike shed.
1999, the guy that, so I think that's really important. And we didn't know, a bit of history. This was an important moment. And I think I'm going to switch the screen now to this, because this is important. So Andrew O, he wanted to set the record straight. No, Al Green, sorry. Al Green, May 13th, he wanted to set the record straight about Varnish, which is the technology that we use, the relationship to Fastly, and the relationship to Varnish Enterprise. And it's all here. So Fastly is not running Varnish Plus, which is a Varnish software product, and they have their own fork. So that is important. It's similar, but not quite the same. What we use is nothing from Varnish software, not Varnish Plus. We're using the Varnish cache, the open source project, as anyone can consume it. So we have built, everything that we built is on open source technologies. And that is important to us because that is in our DNA. So there's some history here, that's important. So we are building on Varnish cache open source. All right, back to where we were. Cool, so we did a thing, and this thing is important, but actually we did a few things over, I think, 4 years. We did quite a few things.
10 years.
10 years. 10 years, yes, 10 years. Okay, 10 years.
Just keep that in mind. Adam's not going to let it go. It's 10.
9 next year.
years later.
Yeah, that's a good one. So they were all good. I think most of the things were good, right, that we've done.
Most of the things were good, but that's not all things.
Right. Shall I fix this now?
No.
No, it's okay. Okay, sorry. My bad. So what are some of the things that you don't think went as well? Let's talk about that. Out of your collective memory, maybe even someone from the audience can tell us a few things that didn't go so well.
S3 costs.
S3 costs.
Yeah, we spent more money we should have on S3.
We're ballooning,
Yeah.
and we didn't know it
Egress. and
until
stuff.
that one Kaizen episode where I finally looked at it. And then I was like, oh, we should change this. We should address this.
The bill went from like $15 a month to like maybe $180 at peak, I believe. Which is still small, but like we're not massive. We're
Lean
not.
operation.
Yeah.
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 That's not cool.
But now we're on R2 and we're spending like $8 a month.
Yeah. They basally pay us.
So now it's
They
good.
should pay us.
They should pay us.
Yeah.
Now it's good, but that wasn't good.
I deleted a few things that I should have, as you do.
Yes.
Right? Flying too close to the sun, it's a good thing.
And there was
perspective.
there was one time where Gerhard went into, I don't know what it is anymore, a config or one of my pieces of code, and he changed something that to me was inscrutable. Like why, what, who? But I had so much respect for the guy and so much imposter syndrome that I thought, surely he knows better than I do.
I remember that. Yeah.
And I must be a
call me
fool.
Shirley.
But it looks wrong. But I'm going to go ahead and roll with it because Gerhard knows
Yeah.
what he's doing. And then I
No.
found out much later you had no idea what you were doing.
No,
Yeah.
I don't know. So this is something really important, and it's like at the heart of what we do, right? We are figuring stuff out, and we are okay to admit it publicly, right? Like we mess things up, but there's no way you're going to learn if you don't make mistakes. Doesn't matter how much experience you have, doesn't matter how many things you think you know, you never know. Let's be honest, you don't really know. You're mostly making stuff up. Some things help you, but it's all in the confidence that you will be able to figure it out, will be able to push through. Just stick with it long enough. That's all it takes. All right, so today we did the biggest thing ever. What was that?
A live show.
A live show, yes, that's one.
We showed up in a city we don't live in.
Right.
People flew here with us. That's a big thing. Is that what you're referring to?
Yeah, that's
Okay.
one of the big things. So,
Okay, what else?
well,
I'm so curious what we did.
What did we do? Tell us.
What did Gerhard do?
Yeah, let's scratch that. Okay.
Yeah,
What
yeah,
did
yeah.
Gerhard do?
Yeah.
What'd you do, Gerhard?
So I did something I will show you very soon. Trust me, it's coming, but it's the biggest thing ever.
Okay.
All right, so the fact that it's green, don't let that mislead you. It's a bad thing. Okay, color, psychology of color is very important. So
What is this?
the 17.93% is the cache hit ratio on our current production CDN, which is low, right? That's really, really low. It means that less than 20% of the requests get served really fast, 80% plus are slow. And while it doesn't really impact us, I mean, it's all good for us, it impacts you. When you load something, it takes a while to load. And it shouldn't be that way, right? Things should be instant, things should be very, very smooth. And when something goes wrong in the backend, for example, if 80% of the requests, they have to go back to the backend, it means that they can fail. So the chances of something failing are fairly high if there's something wrong in the backend, and that's the other thing which I keep thinking about a lot.
Yeah. And it's worth noting that our data is unidirectional. I mean, we rarely change anything once we publish.
Yeah.
Episode 1 is still episode 1.
Yeah. Every once in a
19
while,
years later.
you know, we might put the wrong
18
audio
years.
in the wrong episode, or
Yep.
we might have to edit something that
Or you ship the entire wrong audio.
Yeah.
Like I've done recently.
that Adam did recently. So we make mistakes, and when you make a mistake, you want to be able to quickly rectify it, purge everything, and get back to where you were. But generally speaking, you put an MP3 up on a CDN, and then you deliver that same MP3 in perpetuity.
Yeah.
And so this number is abysmal.
That's
Yeah.
Because, like,
terrible.
we should never have misses.
Yeah.
And that's what I've been saying for 10 years.
Right.
Why do we
10
keep
years.
having cache misses? Okay.
And the problem is that in this case, it's mostly the website. So the changelog website appears slow in a lot of cases, and that's not great. So that was the problem that we were trying, or that was the thing that we were trying to improve. That's how this started. All right. Episode 26, this is what Jared was mentioning when we began. Should we build a CDN? I mean, that was the moment we were thinking, should we do this? I mean, are we really at that point? And it took a while, but the conclusion was yes. I mean, we should at least try and see how far we get. That was 18 months ago. Pipely.tech, we had this up for a while. We talked about it at Christmas. A new CDN is born. It hasn't been updated recently, but it will be. But this is the home for the open source project that we would like others to use at some point. I think it's getting there. It's not quite there yet, but we have made many improvements to make it easier to consume. And this is something that has been bugging me for years. We run on Fly.io, and Fly.io has points of presence all over the world. But our application only runs in Ashburn, Virginia, because it's closest to the database. Of course, it's going to be close to the database, right? Because data has gravity. But we wanted to distribute the application for a long, long time, but it was never the right model. With a CDN, that's exactly what we want to do, right? We want to get those instances all over the world, so finally we can say that after all these years, we are holding Fly.io right. And it's been working pretty well.
Is that the big thing?
I think it is a big thing.
Is that the big thing you were referencing
No,
earlier?
no,
Okay.
it's coming, it's coming. I'm
just
building
waiting
up
for that
to it.
moment. I'm just waiting for that moment.
This is one of the things. We are holding it right.
I want to say one thing too real quick. Leave that there. That slide's good. That slide's good. The next one is good.
Next one?
Yeah, the next one's fine. Let me show some things. But you see Fly here. They're not here. We didn't make this about sponsors. We wanted it to be about you all, us doing a normal live show together that wasn't like, hey, let's charge a normal amount for tickets or whatever it was. We just want to go somewhere, have some fun, get together, and just share this story. But I do want to recognize that Fly and Kurt and the team there have been extremely supportive of us. Not saying you should use them, but they love us, we love them, and what we're building is really on top of the best platform we believe. So Fly is amazing.
Fully agree. Yeah, fully agree with that. Jared? All good?
Yeah.
Right. So this happened about 6 hours ago or 7 hours ago. This is 1 a.m. last morning, okay? Something went wrong. So things will continue going wrong. You will never really get there. It's all about the mindset of, can we do it a little bit better? And again, we are figuring stuff out. So this was yesterday, last night. So this is a question for the audience. Who would like to see us improve this specific crash live?
Ooh.
Yeah?
Yeah.
All right, let's do it. Cool. So what do you think happened here? Just like, let's do like a very quick understanding of what the problem is. What do you think happened here?
Can you describe the architecture of Pipely, like Pipe Dream, in terms of what's running out there?
I can. So it's Varnish instances. I mean, Varnish is really at the heart of it. There's a couple of other components around it, but Varnish is the heart of it. Varnish makes requests to backends. The backends in this case would be assets, for example. We store static assets. We were mentioning MP3 files, PNG files, JavaScript, CSS, that kind of stuff, which rarely changes. Then there's a feeds backend. Feeds stores generated feeds for users, plus members,
Correct.
and shows, various shows.
Every show has its own feed, and then you can also create your own custom feed.
Yeah.
And so there's something like on the order of 600 to 800 feeds, I would say.
Yeah.
8 of which are way more important than the others because they are
Exactly.
publicly consumed by all the podcast indexes.
And those feeds get the most requests from all the platforms, the podcasting platforms that consume the changelog episodes, and they distribute them to their audiences, or to your audiences, but through that platform.
Correct. Yep.
Our audiences.
Our audiences, yes, our audiences, for sure. And what this is, basically, we get these instances that are distributed around the world so that the delivery of that content gets accelerated. The one thing which I haven't mentioned is the applications, the changelog application, the website, which is an important one. That's where many users go to, for example, look at the homepage, look at news, things like that. And that is the one which is most sensitive to latency because, as I mentioned, it's only in one location, close to the database. So we need to accelerate delivery of that website to users which are around the world, including Australia, South Africa, South America, all over the world. We have a very diverse audience. And we want those users to have just as good experience as anyone else that's maybe in the North America.
So in this case, one of our 10?
Yes.
10 instances of the Pipely application
Yes.
crashed.
Ran out of memory and
Misty
crashed.
Bird 4931.
Yeah, Misty Bird, that's the one. Misty Bird crashed. That's what happened, exactly.
Okay, so now to your question
Yes.
to the audience was,
Why do we think the application crashed?
why do you think it crashed?
And anyone can answer except Matt, Nabeel, and James, because they know the
already
answer
know
to
why
this.
it crashed? It ran out of memory.
Why did it? Yes, of course. Thank you.
I appreciate
Someone's
that
paying
answer.
attention. Someone's paying attention. But
gonna be
why
my
did it run
answer.
out of memory? Why do you think it ran out of memory?
Because there wasn't enough memory.
Right. I love some trolling. Seriously now. You're going to make me say it, right? Okay. So as more content gets cached in memory, the problem is there's like a configuration which I wish it was easier to make, but you have to manually adjust how much memory you give to Varnish out of the total memory available. So there's a dance that you need to make so that you know how much is enough so that when more memory gets allocated, the thing doesn't fall over. I wish this particular thing was easier, maybe something that we can improve, but for now you have to fine tune it and find if you have 4 gigabytes of memory total, how much should Varnish be allowed to use? And if you think it's 4 gigabytes, it's way too much. So that's what we're going to do now. I'm going to switch to some live coding and show what happened. So, actually, you know what? Let me try this. How's the font? Can everybody see the font? Can you see what's there? I'll make it a little bit bigger. Yeah, a little bit bigger. Okay, so this is the change. And if I'm going to undo this, you'll see what it was before. So I thought, let me take responsibility of this, I thought that 800 megabytes is going to be enough. This was the case when the application had 2 gigabytes. So when the instance had 2 gigabytes, 800 megabytes of headroom was enough so the application wouldn't crash because of out-of-memory issues. And apparently, when you have 4 gigabytes, 800 megabytes is not enough. So what happened is 33%. 33% should be enough for this to work. And again, you have to specify this explicitly. I'm sure that we'll improve this at some point. This is what this looks like. So we're going to push this change into production live right now. Here it is, here's the change. So we'll say increase varnish memory, or limit, let's do that, limit varnish memory to 66%. 66%, right? Varnish memory can only use 66%. Okay, I committed, what's going on? Of course, I need to connect. Right, let's do that. Let's connect.
You're offline.
Yeah, I'm offline. Let's do this. Again, this is live. Like this is not recorded. It hasn't happened. Let's see. Let's see how this. I normally record these things, but let's see what's going to happen.
Good time to go live, Gerhard.
There you go.
Let me
Let's see.
just read this Bill Gates quote.
Okay.
You thought 800 megabytes ought to be enough.
Yes.
Bill Gates, 640K ought to be enough for anybody.
Right. Right. Apparently
So,
not.
You know, it's not an unreasonable thing that you thought.
Nope.
Okay.
All right. So what happened is we committed and we pushed this commit, this one commit, and to deploy something into production, all that we have to do is tag the repository. So tag and commit. So RC3 is the last one that went out. You can see when it went out, it was 2 days ago. We're going to do an RC4 now. And all we have to do is this. J tag, J stands for just, so I'll do just tag, because I don't want to remember the command, it's quite long. So I'm going to do the SHA. The SHA in this case is going to be, sorry, tag. So v1.0.0 RC. 4, there you go.
Okay.
Nice. We'll just do head, right? Of course, it's going to be head. And the discussion, this is the changelog discussion where you can basically listen about this thing. So this is us preparing Kaizen 20. Remember that GitHub discussion that I talked about, that's what this is going to do. And I'm going to push it now. No, push, git push. What happened? Undefined. That should have been fine. Looks like the connection dropped.
Someone's blocking port 22.
No, the connection
offline.
dropped. Yeah, let me just go back.
Let me read a Bill Gates quote.
Yes, sure. Another one.
Do we not have house internet?
No,
Dear
it's all good.
ChatGPT, give me another Bill Gates quote.
Let's git push again. I mean, just make this, it's slow. There you go, that pushed. Cool, so the tag went out, and what we're going to see now is, actually this one right here, we'll go to the actions. So this is a live, this one right here, 100 RC4, and it's going to push this change into production across all instances. It's going to roll them live. We're deploying this. So why is this significant? Sorry.
Let me set the record straight.
Sure.
Bill Gates in 1996 said, I've said some stupid things and some wrong things, but not that. No one involved in computers would ever say that a
Right.
certain amount of memory is enough.
Right.
So I guess I take it back.
Is that true?
I don't know.
Is that factually
I
correct?
scroll
What is your
further.
source of information?
Yes. So there you go. He may
Cool.
or may not have said that.
So
Let's
let's
watching it roll out.
Let's see. So now we're seeing like a live rollout, and we'll see. So publish and deploy tag is doing all the validation. Go on. It's moving on. It's going through the changes.
Errors.
Yeah, it's saying errors, but it's going to resolve itself. It just takes
Done.
a while.
Done.
Cool. So there you go.
How long does it normally take, Gerhard?
Well, last time I think it took 2.5 minutes.
And
So
you
we
thought
are
this
about.
was a good idea.
Of course, why not? Look, we're already creating the new machines. Look at that. That's going.
All right.
So this is something that I think is important to get right early on. And that thing is, how long does it take you to push a change into production? So how long does it take you to make a change and see that change roll live? And this is something that we've been working on for quite a few years on this thing. We do push to production. We own our production. We don't develop in production. That would be crazy, even for us. But it's like all like this mentality of, if I'm going to make a change, how long will it take me to see that change happen? And if you can shorten that time, you're in a good place.
Yeah. 10 years ago, it took 20 minutes or so.
It was long.
It was a long time.
It was long enough that you go do something else.
And now it's 2.5 minutes maybe.
And this is a global CDN. So
Right.
this is, we are pushing this change to all the instances of the global CDN that we run in. Where do we run them? Let's have a look. So this is it. So we are Ashburn, Virginia. These are the instances. 2 days ago, if I'm going to refresh this, you'll see the new instances come live. So that was 2 days ago. That was like the last deploy. Let's refresh, deploying 57 now. That's the commit. We have new instances coming up. And you can see like we do blue-green. Of course, we need to blue-green. We need to deploy the new ones. The old ones are still there, 2 of everything. It's an important rule. And yeah, this works fairly well. It will not have any downtime. And we can look at that in a minute. So Ashburn, Virginia, Chicago, Dallas, Texas, Santiago, Chile, San Jose, California, Heathrow, of course, London, Frankfurt, Sydney, Australia, Singapore, and Johannesburg. So these are all places where we deploy these instances, and they will accelerate all the content to our users.
Does anybody out there have a deploy pipeline that runs faster than 2.5 minutes?
Does anyone have a deploy pipeline? Let's start there.
I got a hand up.
2 people, 3 people, 4
All right,
people.
so I think we're winning.
5 people, 6 people.
Cool.
2.5.
2.5. Nice.
It only feels long when you're on stage.
Yeah.
Deploy now.
And you're sitting
Well,
at your desk.
this is real. This is real. Like not edited. This is what it feels like. Now, I don't think 2.5 minutes is long. I think we can improve it. But you need to think about all of these need to happen behind the scenes, right? The allocation of resources, the health checking.
Yep.
Like how do you know what you've put out there is correct? And you need to wait a while to make sure that the thing doesn't crash. That's why you need to wait at least 60 seconds before you can say, yep, this is good. You need to do a few health checks. Because if the thing starts falling over, you don't want to leave that thing running in production, of course. Cool. So I think we're in a good place. The one thing which I wanted to show is if I come back here, can you see that? Is that graph looking good to you? Yep, cool. So do you see this yellow line? Yep. This was the instance that crashed. So this one is, there we go, it's San Jose, California. For some reason, there's a lot of requests hitting this instance, and those requests, they don't look like human requests. So I think we may have some sorts of bot situation going on, some sort of, I don't know, LLM trying to learn. There's like a lot of requests. And if I'm going to look at this one, the CPU utilization, this is the same instance right here, the one in San Jose, California. I mean, look just how abnormal this instance behaves. And if I'm going to remove that, you can see all the others. So all the other instances, the CPU usage is fine, but this one is spiking up to 100% because it has a lot of requests. Now, obviously, this is in front of the application, so 5-minute load average. We can also see here, San Jose, California. Yes?
Can we see the endpoints that it's serving?
The endpoints that it's serving?
Yeah,
we can, yes. So let's do like a tiny rebuild right now.
Jared's like, can we do X?
Of course we can.
And in the moment,
of
Gerhard's
course
like,
we can, Jared. Of course,
figure it
yes.
out.
No, we can. We can definitely do this. Okay. So I'm going to switch to this view, and this is the last 7 days, and I'm going to make this a little bit bigger for you to see. And can you see that all right? Okay. So you can see that we're here, right? July 26th. So the application went into production a few days ago. So not all of it, not completely, but we started routing a bunch of traffic to the application to see how well it would handle our users.
Is that the biggest thing we ever did?
Almost. It's getting close.
Still waiting
it's getting
for
close.
this. Okay.
It's getting close.
Okay.
But this basically shows that we had many, many steps towards this moment. And now, together with you, we've shown you how we can update something that's running live, that is serving, I mean, this doesn't sound like a lot of requests, like 1,000, but the granularity is 30 minutes. And we are sending a portion of the traffic, and it's handling it pretty well. And we can see that the biggest users, or like the most requests, are coming from ORD.
Chicago.
Chicago, that's the one. Frankfurt next, London Heathrow, and it's not me running load tests, and Singapore. So these are like and then San Jose, California, right here.
Yeah.
So we are running live traffic, not all of it, a portion of it, but we wanted to see, will this thing continue working well?
Did you know that?
No?
I don't think so.
Yeah. So technically we're not launching Pipedream today because we launched it on Thursday, just me and you.
Exactly.
Yeah.
Sorry, team. we
barely launched it. We launched 1 out of 5.
1 out of 5, yeah.
Yeah, so roughly 20% of requests go through our Pipedream at this point.
So whenever you go to changelog.com, that's it. 1 out of 5 requests hit the new instance. And we're able to see how does it behave with 20% of traffic. And it's working. No one complained. Adam didn't even notice. And that's like one of the best things, right? Like to roll things out. You do it in such a way so that, I mean, it is a big thing to us and to people that understand and know what goes behind it. But to everyone else, did anything change? Because if you do this type of job correctly, all people see is maybe little improvements. And if they're not paying attention, even those they will miss.
They think you're always just badass.
Well, right. I think we are a good team. And the other thing which I want to mention is that while what you see here, again, it feels very, it just happened, right? It's like a small thing. The work that went into it, it was months and months of preparation, months and months of discussion, people joining us, working with us. I want to thank James. I mean, he was the first one that has joined this. Thank you very much. James A. Rosen. Yeah, thank you, James. Thank you. Talking in the various issues, the first one that we had, basically being with us for almost 2 years now, discussing about problems that we thought were problems. At some point we were questioning, like, are we maybe too strict? Are we too demanding out of this? And no, I mean, we want things to be better, and this is why we want things to be better. So James, thank you very much for all the conversations, keeping us like big picture, like that's all objective perspective as well. That was so helpful. And then Matt, right? Matt Johnson, thank you very much for that.
Thanks,
thank
Matt.
you. Just thank you.
What did Matt do?
Thank you. It was all about like VCL and going a bit deeper, just to have like another perspective on VCL. I mean, he has a lot of experience in VCL and Varnish in general, but also documentation, also like a diligent approach to how should we do this so that it's easier for others. And that was like so great to have that help. Now, that was months and months and months of, I mean, again, all of us have full-time jobs. All of us do something else, but in our spare time, we find a bit of time to help others, and this was that. So thank you very much for that.
Matt had a good idea last night. Can I pitch it to you?
Of course, yes, please, yes.
So my desire was a 20-line VCL.
Yes.
You gave me 1,000 lines. Matt says,
we can count.
You guys can just pull most of it out into an include.
Yeah, that's cheating, but yes.
I won't look.
Yeah, of course. Great.
Every time I go to the repo, I'll be like, oh, this is nice.
We can give you 20 lines, Jared. We can give you less than 20 lines, yes. I think that's a very good idea.
All right.
Yeah, you just look number one, like step number one. Yeah,
Yeah.
exactly. We'll Kaizen that for sure.
Cool.
So I wasn't prepared to do this, but let's do it. So we have, this is just, we have like a bunch of targets here. There's one that says, how many lines?
Oh my goodness.
Right, so let's just run that live and see what happens. So how many lines I'm going to tap this. So let's see how many lines we have.
Okay.
961. Like, hang on, let's see what's in Varnish. Hang on a second. Oh, no, we don't want that. This is not correct.
We just want ours.
We just want ours. Okay, shall we change this live? All right, let's see what's going to happen.
Not?
So why not? So we want only VC. Actually, no.
Actually, that might work.
Varnish. No, we want inside VCL. So yeah, that's just like one change. So let's go just file. Do you want to do it?
Nope.
I feel like you're stepping in. All right. So let's see how many lines. How many lines? There you go. So Varnish. Let's do Varnish. All right. Let's see that. Varnish. Sorry, VCL. VCL. Okay. Let's see if that works. There you go. How many lines? There you go. These are the actual lines. All the lines. So 364. That's like the main one, and these are like the includes. 24 in this one, and 106 and 15.
Right.
How many total? Less than 1,000. I think it's less than 1,000. 500?
Yeah, ish.
Getting to 500, between 450 and 500.
A lot of these are just like static
Any
redirects.
savants out there do the math yet? Do the
Yeah.
math.
So again?
Any savants out there do the math?
Look at that. 15. This is how we do it. 106 plus 24 plus 364. Look at that. 509.
509.
509 lines.
Okay.
So there we have our answer. Cool.
Right.
So it's still good, still good. All right, so.
Did you want to thank Nabeel?
Yes, of course. Nabeel. How could I forget Nabeel? Of course. So one really important thing is that Varnish cannot terminate backends which have SSL in front. So if the backend is talking HTTPS, Varnish cannot use it out of the box. Varnish Enterprise and other products can, but the open source Varnish cannot. We did a bit of digging, and we realized that's how we learned about Pool Henning Camp, PHK for short, and he was always against including SSL anywhere near Varnish because it would complicate things too much. SSL is really, really complicated. So with Nabeel's help, we wrote, I don't know, like he wrote 50, 60 lines of Go code that intercepts all the requests going to those backends, terminates SSL for Varnish, and presents the request unencrypted. A really simple, elegant solution, one of the almost like sidecars that sits next to Varnish and helps it terminate requests which need SSL. So I'm not sure if that...
Does that do you justice, Nabeel?
Genius.
Yes.
Absolutely genius.
Let's hear it for him. Nabeel.
Good job, Nabeel.
And his
Thank you,
SSL termination.
Thank you.
Okay.
TLS Exterminator.
TLS Exterminator.
That's the one.
That's a good name.
Cool. All right, so coming back to... Okay, so we improved it. We're here. We did it. Kaizen 20. One more thing.
Okay.
This is too far out. This is too far out. Too far? Actually, no.
Oh, we're good.
Yeah, we're good. We're good.
Yeah,
Okay.
we're doing good.
Anything else you want to cover before we do this? There's one more thing that we're going to do.
One more thing.
Kaizen 20. Any thoughts? Any comments from the... I mean, you're here. Do you have any questions? Do you have any comments? Do you have any thoughts? Anything?
We got a question.
We're among friends.
You want
Yes.
to come to the mic? Or,
Can we talk
Okay.
about how we're using Dagger?
All right, okay.
All right.
I can show you. How about that?
Yeah,
okay,
show 'em.
Cool. So there is one very tiny change that I have here, which is using --cloud. This is an experimental feature that exists in the Dagger CLI. The reason why we do this is because we need a remote engine, a remote Dagger engine, so that everything that runs in the context of Dagger is quicker. Over Wi-Fi, it would be over like my tethered connection would be very, very slow. So how we use Dagger, in this case, let's go here. We have a couple of commands. The one I think that's the most interesting one, for example, for running tests. So let me show you what that looks like. I'm just doing just test. You can see there it does like the --cloud. Let's see how fast it goes. It starts an engine in the cloud, it connects to it. So we need to set up Varnish. We need to connect Varnish to all the backends, the TLS Exterminator, and we want to do it in a way that is as close to production as possible. So it's almost like we want to run the system as it runs in production, but we want to do it locally. Okay, in this case it's a remote engine, but from the perspective of how it gets put together, it's literally just the same context of running containers. And because everything runs in containers, we get the exact reproducibility that we get in Fly. So we get the same configuration, the same Linux subsystem, the same kernel, or like a very similar kernel. And what that means, I mean, in this case, it's even using Firecracker behind the scenes, so it's very close to Fly. So we are able to test the system most accurately, and we're even able to run the system most accurately as it would do in production. And that part is hard because whatever you do locally, if I was running, for example, on the Mac, everything would be different. Even if I would have a VM, things would be different. So it's like that containers, the container image, the interaction between all the components, and when we ship something in production, it's as close as possible to that image. Even down like to the Go version. So right now, for example, what's happening here, we're pulling down, I mean, some of it is cached, we're pulling down various dependencies, and you can see they're all Linux ones. So Linux, and again, a VM on a Mac, it gets you close, but it's not the same thing. You get like subtle differences. I'm not sure if that answers your question. Yeah? Cool.
Good use of Dagger. Any other questions before we
In the back?
do the big thing?
I think Nabeel had one, was it? Yeah.
Does Varnish only cache to RAM, or does it also use disk?
So it can use disk as well, but we don't have disk configured. So the configuration is cache to RAM only. It is the fastest one. If we have disks, as you know, the problem is the host, they can't move around. So it's no longer stateless. That has certain challenges about like placement, but also disks tend to be a little bit slower. Not by much, but a little bit slower. As an optimization, it would be worth exploring that, especially with NVMe disks, which is what we would get in Fly. So that is something as a future improvement, but right now everything gets served from memory, which is exactly what happens in Fastly as well.
Right.
Because that's what gives you like that highest performance.
So follow up to that. our crash last night was because it needed more RAM than we allocated to
That's
Varnish.
correct.
And in Varnish, there's no way to say, just use all the RAM available.
So if you tell it that, it uses more than it has available because it tries to allocate more than you have. So you need to set an upper limit.
It can't know how much the machine has?
Well, it knows, but it doesn't do the allocation correctly.
Is that a bug?
I don't know whether it's a bug. It's just not working well with the system available to
That's
the
a
host.
bug.
Maybe.
I mean,
maybe. I
it's-
mean,
Varnish is how many years
okay,
old?
So 20 something.
20-something. There's no way
Yeah.
that bug is a
Okay,
bug,
so-
right? It has to be a decision.
Right. So I gained a lot of respect for memory specifically and memory problems because they're very, very hard. I spent maybe 3 years optimizing memory allocations on the RabbitMQ team for RabbitMQ in the context of Erlang. And I've learned that there are so many subtle differences between how memory gets allocated on different runtimes. In the case of Varnish, obviously it's C, so it's as efficient as it gets, but it's very difficult to know how much you should allocate ahead of time and what you should free, timing, like something has somewhere to give. And usually what you need to do is over-allocate. Basically, you give it more than it needs so that when you get these spikes, right, there's like enough for it to spike so that it doesn't crash things over. Memory these days is cheap, so honestly, like skimping on that is not worth it. And there's a couple of ways we can go around it, like disks is one of them, limiting what Varnish can do, but also seeing if the Varnish memory allocation can improve.
Right.
Because I know what it takes, for example, what it took in RabbitMQ to do that. It took me years, and I was like full-time on that, so it took a while, including to understand what happens behind the scenes. So you need to break it down in a way that you map and observe everything when it comes to memory allocation, and then you realize what needs to be tuned to your use case. That's the other thing, because every context tends to be different.
Sure.
So the allocations, they are generic to make them configurable to you or specific to you so that they're optimized for your use case. It takes a bit of understanding of what you actually need.
Yeah. I'm probably reducing it down too much, but I feel like you could just say, this machine has 4 gigs. Just
Yeah.
use 3, and if you need more, you got another gig on there.
Right, so
Just don't crash.
Yeah, true, yes.
You know?
Yeah,
But my question, my follow-up, I guess, would be, assume that we figure that out, that little dance.
yep.
What happens when our instances become overwhelmed? Varnish might not be crashing, but maybe it's slowing down, maybe the machine's bogged, can't do stuff.
Yeah.
Is there an auto scale? I mean, the answer is more RAM on the fly instances or more fly instances in other
Yeah.
regions or in the same region.
That's right. Yeah.
Right?
So there is a big difference between regions, by the way, and this is something like this is the sort of thing that you only realize once you start using it. Okay, so these are like the last 24 hours. I'm not going to refresh. It's a little bit outdated. I did it like you can see here. It was 10:42 a.m. So it was this morning before we started recording. And what you can see here is this one, the San Jose, California, the SJC, is the one which shows like the highest fluctuation. A lot of these, like once they load up on memory, like Heathrow, they tend to be fairly stable. But then you have a few, for example, this one, Santiago, Chile, this is like 2.3 gigs. So this one is not using all the available memory. This next one in Sydney is 1.84. And you can see that the memory is decreasing because it doesn't need, I mean, this is something, I'm not sure why it does this, for example. I wouldn't expect this line to go down. I would expect it to stay stable. So I'm not quite sure what's happening here. But this one, the lowest one in Johannesburg, it's using 816 megabytes of RAM. So this shows you there is a difference between different regions and how many requests they need to serve.
Sure.
So what I'm thinking is we should optimize for the regions that we have, and the ones which are busy, we should give them bigger instances, maybe beefier instances, but others, like Johannesburg, doesn't need that much. So maybe and the problem is you can't use different scaling strategies for different nodes, and they have multiple deployments, so it complicates things a little bit. But this is a refinement.
Yeah. I think we need more listeners in Johannesburg. I mean, what's up with that?
Exactly.
That's what I was thinking.
That's what I'm thinking. All right, there was one other question out there, I thought.
It was
Hand up.
back here.
Yeah.
Okay, yeah.
Yes.
I like
Go
it.
back and
Okay,
see
so
what the paths look like in San
Right,
Jose.
so-
I forgot about that. Thank you.
yeah, thank you very much. So we're looking at Honeycomb, and one of the integrations that we have in Pipedream is we are sending every single request to Honeycomb and some requests to S3. So like we see what's happening with these instances. So what that means is we are able to, for example, if I come back to the boards, again, let's hope the tethering works. It will be a little bit slow. Okay, so let's go pipe dream requests, and I think maybe pipe dream content, but let's go requests. We can see the get, okay, and now we can slice them and dice them. The 404s and the 500s. So maybe let's do gets. Okay, so let's go to the method, and the only thing that we need to do, so this is 1 hour ago. So these are all the requests in the last hour, and we can say, give me the URL, which is what we've been asking. So group by URL, and what this is going to show us is the get, but also the number of requests. So what you see here is that the most popular request is podcast feed, which got 203 requests in the last hour. And this is global. So we can do one more. We can say, let me remove that, and let me remove request, and let me do data center. So we can see which data centers hit the most. So let's go that. And we can see that Frankfurt, 71 requests went to podcast feed. Chicago, the next one, 47. San Jose, California. So these are the most requested URLs. If we zoom out a little bit, let's look at the last 7 days, so we get like a bigger perspective. I did do 7 days. Okay, so you can see when it went live. So you can see that for some reason, this one, I don't know who this person is, uploads 9,500 times. Shall we go and check who this is? I don't think you'll know who this is. Avatars.
Somebody has a stalker.
People. Let's see. Okay, so let's go to changelog.com. No, let's go. Where is it? Where was it? Not this one, this one. Okay, let me copy that. Copy pasting, hard. Uploads, and I think this will be
CDN. Yeah.
CDN. There you go. So let's see who this is.
Oh, yeah.
Someone, you have a stalker, or a few, who knows?
Who is that guy?
Yeah. Do you recognize him? Who's this other guy? Like 6QD. So that's Z4 or
Yes.
Z4.
Z.
As you say it over here.
over here.
All right, cool. All right, so let's see, what's this next other person?
This is a fun side quest we're on right now.
Why not?
It's K-Ball.
K-Ball. There you go.
Who's in on it?
Shall we keep going? Do you want to find who this person
Let's
is?
see all the... No. Yes.
That's like the third most popular
I
one,
guess there's
so
only 3.
we might as well.
Come on, be Adam. Be Adam.
Adam, let's see. All right. Let's try that. Uploads. There you go. Nick.
So somebody is loading maybe a JS party page way too many times.
That's possible.
Oh, yeah.
But it will show up here, if it was the case.
True.
Is that
But then we have like this like
dysfunctional maybe
randomness
doing
thing.
something?
What's
Randomness
that?
thing.
Is dysfunctional doing something with something?
Oh, on their website? Maybe.
Because they're
So,
connected there.
you know what we could do? We could do user agent.
I think someone's hot linking us, man.
Let's do user agent, and we'll see where these requests are coming from.
It's going to be a robot.
Empty string.
Oh, you
They
didn't
don't want to be known. Okay, shall we
Masquerading
do
and hiding.
Let's get to the
Yeah, go on.
San Jose URLs. This is what we're trying to get, right?
San Jose URLs? Okay, let's do
Filter
that.
to San Jose,
So
all
let's do,
URLs.
okay, so it's not even here in the list if you look at that. And look, this one has an empty string, so that's really interesting. We have somewhere an issue, so this needs to be, or, no, hang on, this was like when we were doing the testing, so maybe that's one not so much practical AI. All right, okay, so let's do server data center equals SJC,
Yeah.
run query, and let's see what do we get. Most popular in San Jose.
Cool how you can do all this
Pocket
slicing and
casts.
dicing.
Yeah, that's really cool, isn't it?
It's so awesome.
Look at that, pocket casts. This MP3 was requested a lot, 428 times. Changelog, is this the last episode?
Yeah,
103?
that one just went out yesterday, right?
There you go.
Is it?
So it's,
Yeah.
it's just a popular episode in San Jose.
That's it.
Well, that's better than I thought it was going to be, which is a hacker.
Yeah,
coming
no,
after
this
us.
is good.
Popular in Cali, not a problem.
Look, overcast. Pocket cast and overcast and
Yeah, they're
Tenapod.
just downloading stuff.
This is good. This is good traffic.
We love it.
Yeah, nothing
All right,
wrong with
very
that.
cool.
Cool.
Okay, any other technical or otherwise questions from the audience
Comments, anything.
before Gerhard does his big reveal? All right, everybody wants to see what you got, Gerhard.
All right, let's do it. Cool. So, coming back here. It's the one more thing. This is the important one. No, that's something else.
Okay.
Cool.
Flash something.
All right, I flashed something, yes.
Let's leave it right there.
So what we're going to do now, we are going to shift
Oh,
all the traffic
all the traffic.
to Pipedream, right? So
Every-
all the
Do it.
production traffic
Last-
is going to go to Pipedream. Shall we do it?
Get your
Yes, of course
podcast.
we should do it. That's why we're here.
All right, so this is the moment. So all that we have to do, this is how simple it is.
It's always
okay?
DNS.
No scripting, it is. No automation, it is DNS. It all comes down to that.
Yes.
We are going to delete these one by one.
These are the A records which are pointing to.
Pause. Let me get my own recording of you doing this.
Go for it. Okay, Kaizen 20 in Denver. Let's do that.
This is going to be anticlimactic because you're going to
Oriental.
delete those and then we'll be like,
Theater.
they're deleted.
Now, if this one goes down, so let's see if the system can handle all the load, right?
Okay.
Like what can happen? So after this, the only requirement is we walk away, okay? We do this thing and we go for lunch or something like that.
That's what's
Cool?
next is lunch, I think.
All right, so boom, we have 4 more to go.
Okay, so now
3
we're-
more to go, sorry. Yeah, after this one, 3 more to go.
It's not deleting.
It's not deleting,
Okay.
it's slow, right? It's
Okay.
my
Shout out
tether.
to DN Simple, big
Right.
fans.
Thank you very much. One more, cool. And the DNS is like one by one. So more and more requests are going to go to this one,
Right,
which is the pipe dream.
The pipe dream.
The pipe dream, there you go.
All right.
So delete,
So we're at 1 out of 3. Now half.
yep,
our
1
tra-
out of 3, yeah.
Now half our traffic will be going to pipe dream.
Yep. Look at that.
And now 100%.
Now, we have one more. So we're 50-50.
What's this one?
That was it.
Let's CDN.
That's CDN. We have to do the same thing for
You
CDN
gotta
as well.
delete the CDN ones too.
There you go.
All right.
And
So this
let's
is
see.
app requests now.
Is this
yeah,
goodbye to
this is-
Fastly?
This is it.
This is the farewell to Fastly?
This is it.
Assuming
This is
that-
a
This is the
triumphant
moment.
moment and a memoriam at the same time.
only if it works.
Only if it works, yeah.
If not, we have to go crawling back to them.
may need to add these back.
Like a dog.
We still love you,
returning to his
Fastly.
owner.
Yeah. If this crashes and burns, we'll have to go back for sure.
The good news
All right.
is they have no idea what we're doing. So,
Yeah, exactly.
no.
And this is not a live show, so we're not streaming
That's
this.
right.
So it's okay.
That's right.
It's in this room. And
Amongst friends.
If it doesn't work
We're
out,
amongst
we
friends.
edit this part out. So that's okay.
He always says
Right?
that, we never do, okay?
Cool.
We ship
does.
it all.
There you go. One more to go. I think this is one, and one
Okay.
more to go.
Now, how
Look at
long is
that.
it? We're at 60-second TTLs. So this should be
60-second
fast.
TTL. They should be fast, yes.
All right. If you can get your phone out and hit our website, please.
Yeah. Let us know how it goes, but that's it. We only have
Let's
these
generate
two.
some traffic.
Where's the real-time dashboard showing the
Real-time
activity?
dashboard,
Let's
of
go real
course.
time.
Let's do that. Let's do last 15 minutes. Let's see everything crash and burn.
Oh my gosh.
No.
What's the worst thing that could happen? Okay,
Well,
there's
the worst thing that
traffic.
could happen is all our fly instances run out of memory.
Well, there's no peaks and valleys.
Let's
so
go back
far.
to here. Let's go to the memory. There we go. Every 1 minute. Let's maybe go to the last 1 hour. So let's see. We had like a spike there, but this is like 12:20. So I think it's still good. I think what we're going to see. So 2 things we're going to see. We're going to see. Let's come back here to the pipe dream requests. We're going to see a change. Like these requests will start going up. More and more traffic is going to start hitting. Look at that.
Oh my
Like,
goodness.
that's boom. That was like the spike right there. More requests getting resolved here. Status, still 200. That's good. So that's all good.
I'm going to our website.
And 404s, 500. So things are looking good. Let's see, what else do we have? Let's load a few more boards. And the opposite is obviously in here, in
loading for me.
Fastly. Nice. So it kind of works. Still.
Works on my machine.
It's so fast.
Fastly service stats. So these are Fastly service stats. The request went up as well. I'm not sure what happened there. Why did they go up?
Because I just told everybody to go do it.
Right.
All 30
I
of
don't
us
think
are
we have that
hitting
many
that
people
thing
here,
hard.
but still. Cool. So there's the requests. All good?
Boys,
Playing MP3s.
let's play an MP3.
Nice.
Latest show.
Let's do pipe dream service. So there we have a few again. The cache, we can see things going up here. So this is last 7 days. We'll need to zoom in a bit. So let's go 24 hours so that we see the spikes. There you go. That was the spike.
Yeah.
So
And what is that spike?
this one is more hits. That's good. More hits. We're getting more hits. That's good.
More hits.
More
so
hits.
it will take time
That's what
because
he
the real
wanted.
question is, was it all worth it? And the answer to that is, well, do we fix that cache miss ratio, cache hit ratio, right?
Let's check it
That's
out.
the actual answer to the question.
What's the
Look at that.
17%?
Look
Yeah,
at that.
let's,
Look at that.
are we going back to that?
So let's go back to that. Let's look
17% cache hits.
last 24 hours. This is the home page, right? That's the one that we were focusing at.
Sure.
So we're looking at the home page, last 1 day. we had 3,700 hits,
Yes.
and we had 33 misses.
I think that's better.
That's better.
It is better.
That's much,
It is
better.
better.
We Kaizened it.
How
It's
much is
better.
that? We did it. No way. No way.
Do the math on
Let's
that.
see. 3,715 plus 33. That's 99.1%
Woo.
hit rate.
That's a lot of nines.
Yeah. 2, to be exact.
That's 2 nines.
That's way more nines than we
That's
used
2
to.
nines.
More than we had.
There are some
It was like
nines in there, is the
17%,
point.
17%. So this is much better. All right. So obviously this will take a while, right, for all the traffic to start shifting through. It is DNS, right?
Yeah.
It's cached. But things, look at that. Things are happening.
We did a
Things are
thing.
happening.
So theoretically, 60 seconds later, those TLS records should expire.
Correct.
Exactly.
And then require a new hit, which goes to
So
a
let's
new
do this.
route, which is through
Dig changelog.com. And changelog.com right now, for me, it returns a single IP address. That's it.
Bam.
And
because
this
we're
is
still in Ashburn.
no,
right?
this is the pipe dream
that's
IP
the pipe
address.
dream right there.
This is it. So this is one. And if I do changelog.com, this is the DNS that updates the quickest. That is the Google DNS. That's very fast. So Google DNS knows we're up. There's also, I use DNS Checker. Let's see if it's still a thing. It's been a while since I've used DNS Checker, a service that checks, tries to resolve the IP address from a couple of locations, like more than a couple. Let's see. DNS Checker. Let's go changelog.com.
Try CDN.
What is the, we'll do CDN as well. Changelog.com, this is the, I think the important one. So all the DNS is San Francisco, it is. I'm going to make this a little bit bigger for everyone to see. That's the new IP address. We can see all the locations.
updated.
So all of it is the new IPs. We don't see any of the
The
old
world
ones.
knows about what we did.
Yeah, I think so. They took notice. I think it's been good. I think. Yes, question. That is a fly.io IP address, yeah.
That is a
yeah.
fly.io
So
IP address.
Let
It's the fly
me show you that.
proxy.
So we have just IPs, right? We can see what IPs the CDN is using. And you will see that it's this IP address, which is a dedicated one. That's the IP that we're using. That's it.
Should they clap now?
Only if you want. Only
did
if it's
it,
good. Thank you, thank you.
Mind blowing.
We did a thing.
We did a thing.
Thank you. Thank you. Thank you. Because you were a part of this. And we did it with you and for you, and this was so good. Thank you very much.
Thank you. So a couple of special thanks. We've already thanked our Pipely folks. Thanks to a couple of Denver liaisons. Dan Moore. Is Dan here? Hey, Dan, how are you?
Dan!
Good to see you. Thank you, Dan.
Thanks.
And Kendall Miller. Did Kendall leave, or is he still sticking around? He left. He was here earlier. Thank you to you two for helping us find this theater, for helping us connect with Nora again after all those years. We don't live here, and so I had no idea what I was doing or who I was talking to, so always awesome to have locals and friends willing to help out and make it awesome. So
It was great.
that's our show.
One person didn't get thanked.
Yes.
Jason.
Oh yeah, Jason. Where is Jason?
Come up here,
Over
Jason.
there. Look,
There's
Come up
Jason.
here.
There.
Jason,
Hey,
come
Jason.
here. Jason's our editor.
He's behind the scenes, but he's very much part of this team. He doesn't get seen.
Oh.
He gets mentioned a lot, but critical behind the scenes here at Changelog. Thank you, Jason.
Thank you, Jason.
Thank you.
All right, anything else, Gerhard?
Thank you all. I really
Yes,
appreciate it.
thank you.
Really appreciate it. Thank you all.
Really
Thank you.
appreciate
Yes,
y'all
thank
coming.
you.
Thank you.